Hello everyone, it's your now assignment tutor again. Now a question in physics was brought forth to me, and this question is on mechanics. It's just an application of Newton's second law of motion. Now let's look at the question. This is the question. Now look at the question. It said three masses A, B, and C are connected by light in inextensible string as shown. B is this is B said on a rough horizontal table which has a coefficient of friction. This mu. The coefficient of friction, which is mu, is 0.6. The pulley are smooth. When B is released, what will be the acceleration of the masses? So they asking for the acceleration of the masses, then they also find the tension in this string. This the tension. Now, the way I solve it in secondary school, I want to show it to you. Very simple. Now we're looking for the acceleration first. Now from Newton's second law, of motion, we know that net force, which is NF, that is force, the net force of the system is equals to the total mass times acceleration. The net force of all the system is equal to the total masses times what? Acceleration. The net force is the weight force or the differences in the weight forces in the system. Now, what do I mean by weight force? If you have mass M1, M2, M3, M4, like that, the weight force, the net force is always equals to M1G minus M2G minus M3G minus M4G, like that. This is actually the what? The net force. Now this net force, why did I put this modulus, this sign here? This sign here means that is going to be a positive value. So you cannot get negative value for the net force. It's going to be what? A positive value. And when you are solving the question, there are some times you may get a negative acceleration due to because of the friction, and depending on the direction of the force, depending on the direction of the force, you may get negative acceleration. That means that the negative acceleration will be showing the direction of the system. Now let's look at the system body for us. When this is 4 kg mass, this is 3 kg on the table, 1 kg is on the table. If you look at it critically, you will discover that the direction of this system, when you release B, it will move in this direction because this 4 pulling the rest is high in mass. So the direction of the acceleration will be here. It will be in that direction. And we want to establish that the frictional effect, which I may call F subscript R, will be towards this side. The frictional effect, because the frictional effect, we always oppose the motion. So it will be towards this side. So when calculating your net force, you need to take into consideration the frictional effect opposing the motion. You need to take into consideration the frictional effect. Now, because now that we have introduced friction, so another way you can say net force can also be M1G minus M2G minus frictional force, like that, something like this, frictional effect. In case you have two masses, this is how you do it. There are sometimes you may have only one mass, so you just say net force is equals to what? M1G minus frictional force. So these are different ways to find your net force. So let's quickly jump to the question and solve it. Now they ask us to find the solution, and they tell us to take G as 10 meters per second square. So from this formula now, we can say acceleration is equal to F net over total mass. F net over what? Total mass. So what is the net force? The net force will now be, now let's take this one as M1. So that will be M1 times, this G here is the acceleration due to gravity, which is this here. So we are going to take 4G minus 3G. Now, this 3 here is actually not is not hung on gravity. So we cannot take 3G here. Why? Because it's on the flat surface. So we are going to use this minus G. This is 1G. It's empty as 1G. It's empty as G. For this one, G. Then we are not going to use the frictional effect, which is what? FR. The frictional effect, which is what? FR. Over the total mass, 4 plus 3 plus 1. The total mass. So, having done this, we need to actually find our friction, because they said the coefficient of friction is 0.6. According to law of static friction, FR is equal to mu times what? R. FR is equal to what? Mu times R, which is what? FR is equal to 0.6 times R. Now, this R is called the reaction on the horizontal table. The reaction at the horizontal table, which is this place. This place. The reaction at the horizontal table. And this reaction, according to Newton's third law of motion, he said the reaction is also equals to the force acting on it. Therefore, reaction is equal to the weight force, which can call 3G. That's 3 times 10. We still leave it as 3G. We are still going to make use of the G later on. So let's come here and say FR is equal to 0.6 times what? 3G. So when you multiply 0.6 times 3G, that gives me 1.8G, because 0.6 times 3 is 1.8G. So we go back and slot it into this. So we have acceleration equals to 4G minus 3G minus 1.8G. That friction we find over what? What is 4 plus 3 plus 1? That is what? 8 kilogram. So we are going to have acceleration is equal to, no, this is not 3G here. This is G. Sorry, I'm sorry. This is G. Because what we have here is G. This one times G, that is G. So 4G minus 3G, that is 3G, minus 1.8G over 8 kilogram. So 3 minus 1.8, that is 1.2 G over 8. So 1.2 times 10, because they take G as what? 10. 1.2 times 10 over 8. That gives me 12 over 8. 1.2 times 10 is 12. So let's simplify it. 4 here 3, 4 here 2. So you have acceleration is equal to 3 over 2, which is equal to 1.5 meter per second square. So this is the acceleration which the body moves. That means it's moving with the acceleration of 1.5 meter per second square. Now they ask us to find the tension. Now for this, the weight is coming down, which is 4G. The 4G is pulling down. So the tension will also be coming down, which is T1. Now for this, because of the tension is coming down, is downward, So you are going to find the differences. That is the concept. Because the tension is coming down with the 4G, so it will be differential force. It will be differences of the force. Now, the force causing it to move, which is actually, according to Newton, is actually 4A. The force that made this one move is 4A, that enabled it to move. The weight force on it is 4G. That is down, is towards the down. Then the 4A is the force that enables it to make the weight move downward. Since they are moving downward, that means for T1, 4G, because it's moving downward, is greater than what? The 4A. Because why is it greater? Because it's moving towards the weight of the 4 kilogram. So you are going to have T1 equals to 4G minus 4A. So we have T1 equals to 4 times 10 40, then 4 times 1.5, which we find here at that time. That is 6. 4 times 1.5, that is 6. So T1, sorry, equals to 40 minus 6, that is 20. No, that is 34 Newton. That is 34 what? Newton. So the T1 here is 34 Newton. Let's find T2. T2 is pulling up. So the force that enables it to move up is 1A, which is same thing as A. 1A. And the weight force is actually down towards the down. But the 1A is moving it upward. So it will be the addition. So for there to be proper movement of the force of 1 kilogram, you have to add the weight force and the force that made it move. So you are going to have T2 equals to G plus A, because it's 1G plus 1A. So we're going to have T2 equals to 10 plus 1.5. That gives me what? 11.5 Newton. So that is all. We have solved the question. So our acceleration is what? 1.5 meter per second square. The tension is 34 Newton. T1 is 34 Newton. Then move it downward. 34 Newton downward. Then T2 is 11.5 Newton upward. So that is the answer for the question. So do have a wonderful day. Subscribe to my YouTube channel. As I drop some questions, you'll be the first to actually view them. Bye-bye. See you later.